friends.
Hello class, we're about to start lesson 2-7, keeping current. Our learning objectives is to decide on an appropriate type of model for a given data set, to model data with a linear or exponential equation, and to research current data to compare to values predicted by a model. All right, so we go down here to the bottom of the page. Again, we're on page 191. And it says, if you're like many students, you're concerned with the cost of attending college. It's certainly not a secret that college tuition has been rising rapidly over the last 20 to 30 years. But what are the facts? For that, we need some data. The table below lists the average tuition cost for all public American colleges and universities for a variety of school years starting in 1981. Now, when we go over to page 192, it says here to analyze the data and look for patterns. We've seen that scatter plots can be useful tools. We've also seen that when modeling data based on time, it's a good idea to choose input values based on time passed since the first data value we have. In this case, we should use inputs that correspond to the number of years since 1981. So, what I'm going to do, and you can pause this and look at this here, but if you notice, 81 would be our 0, and then 1991 would be 10, and then this would be 2001 would be 20, and then this would be 21 all the way up to 30. So I'm going to mark that. So the X values would change according to since 1981. So it'd be 0, 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. But the Y values will remain the same. So it'll be 2,663, 5,138, 8,022, 8,502, 9,247, 9,864, 10,454, 11,049, 11,573, 12,256, 12,804, 13,564, and finally 14,292. Now it says here, draw a scatter plot on the data in your table. Make sure you choose an appropriate scale for each axis and clearly mark that scale on your graph. Okay, now, if we look here, this would be our 0. And we know also this would be our 0 on the y-axis. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be 15, 20, 25, 30, all the way up to 34. So we have 34 values. If you notice with our years for X, we go from 0 to 30. So we can actually go by ones here. So this would be 5, 10, 15, 20, 25, 30, and we know we'll go to 34. Now the average tuition, if you notice, the lowest amount is 2,663 all the way up to a little over 14,000. So we could count here. We got 1, 2, 3, 4. 1, 2, 3, that's 8. That'll be 12, 16. So we got 17 tick marks here. So I'm thinking with 17 tick marks, if we make each one of them 1,000, that would take us above the 14,000. So this right here would be $4,000. This would be $8,000. This would be $12,000. This would be $16,000. So now we have all of these marked. Now we have to go and graph this. So now we have 0, 2,663. So this will be 1, 2. And this, we know that 2,663 is in between 2 and 3,000, a little closer to 3,000. So then we'll go to 10. It's a little bit above 5,000. This is 5,000, a little bit above it. Then we'll go to 20. And we know that's a little bit slightly above 8,000. And then we will go to 21. 21 will be slightly past half between 8,000 and 9,000. 22 would be a little bit above 9,000, real close to the middle. Real close, well, closer to 9,000. Okay, and then 23. Let me see, we got 9864. That'll be close to 10,000. So this would be, let's see, 8, 9. This would be 10. This would be close to 10,000. Okay, 24. We have a little over 10, almost half, between 10 and 11,000. 25. We'll be a little bit over 11,000. 26. A little bit past half, with 11 and 12,000. 27. A little bit, well, close to the halfway point of 12 and 13,000. Wait a minute, 26, 27. Okay, yeah, that was 27, close to half. 28 will be very close to 13,000. 29 will be a little bit above half, between 13 and 14,000. And then finally 30 will be close to the middle, between 14 and 15,000. So these are our points. All right, so now we move on to the next page. Now we come here to number 3. It says, based on your scatter plot, which type of equation do you think will most appropriately model the tuition data, linear or exponential? So to me, when I look here, this looks almost like it's forming a line. Or, you know what, no, actually looks like it's more of a curve. So I probably would go with exponential. I say exponential, and it seems to curve upward. Now you can make an argument for linear as well, because most of the points are almost in a line, so you could make that argument. So number 4, using a graphing calculator or a spreadsheet, find the linear equation of best fit for your data. Round all coefficients so that they have 5 digits total. So we will go right here to our calculator. So we're going to put in all of these values. We'll go to our table. And remember, the table that we're going to list is the one since 1981. So we have 0, 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Now we go back to enter the amounts. All right. All right. So we entered all of the amounts, and we're asked to find the linear equation. So we will go down here, and remember our linear formula is y equals mx plus b. But if you notice here, we got y1 and x1, so we have to indicate that. So we'll put y1, then we'll go to this table here, And we will go to the ABC and get this tilde here. And then we'll do mx1 plus b. Now, we have our slope and our y-intercept listed here. So, we will write our equation. Now remember, we must have 5 digits total. So our m is 385.659. So we add 385, that's 3 digits. So we only need 2 behind the decimal. So it'll be 0.66, and then we will put x. Okay, now our b. Our b will be 1501.2. I just have to make sure that I didn't, let me just make sure. I should have checked this before to make sure that I had all of the values in correctly. Oh yeah, I have all of them in correctly. Okay, so this is our linear equation. Okay, now it says graph the line of best fit and your scatter plot on screen. Based on the graph, how well do you think your model fits the data? All right. So I'm going to have to expand this out a little bit so we could take a look at this line here. Now the problem that we have here is that how large these values are. So what I'm going to do, I'm going to take this wrench here and I'm going to make the x value the x-axis. I'm going to start it at 0 and then go up to, let's see, 40. And the y values, I'll start at 0 and then I will go up to 20,000. All right, now that's a lot better. If you look at this line here, you notice that the line of best fit, it doesn't hit that many points, but that doesn't mean that it's not a good fit. Okay, so this is not as good. Let me gotta make this a little smaller so we can see the page. So it'd be not as good because the earlier points cause the line to tilt. Now the earlier points cause the line to tilt. All right, now it says, what is the correlation coefficient for your equation of best fit? So if we do the R here into 2 decimal places, you look here, the correlation coefficient would be 0.97. Does this change your perspective on how accurately the model fits the data? Explain. Well, for me, I would say, well, you could say yes, because the correlation coefficient is real close to 1, which means it is a strong correlation. And then you can put in parentheses fit, so it'll be a strong fit. And then I'll put also here, but not perfect, because 1 would be perfect, so but it's not perfect. Strong fit, but not perfect. Okay. So with that being said, We're going to mosey on over to the next page. It says, write a description of what the slope of your linear model tells us about the growth of tuition since 1981. All right, so with our slope, the slope is 385.66, and we know that's dollars. The slope is $385.66, which means tuition goes up each year since 1981 by $385.66. Number 8, it says, now use your calculator or spreadsheet to find the exponential equation of best fit for the data. Again, round all coefficients so that they have 5 total digits. Okay, so we know we're looking for y equals ab to the x. So we don't need to reinvent the wheel. We already put it on the table. So now what we're going to do, we're going to put this in for the exponential regression. So we have y1, we'll get our tilde, ab, then we'll take this to the x1 power, because remember it's y1 and x1. Now again, with the exponential regression, you have to click this log mode. Do not forget to click the log mode or you will not have the correct answer. Now, we need to write down our equation. Y is equal to, now we're supposed to have 5 total digits. So we add 2757.0. So that's 5 digits for our A. Our B is supposed to have 5 digits, so it'll be 1.056. So far, that's 4 digits. So then that last 5 will become a 6 into the X, because we rounded. Okay, now we have our equation. Now, number 9 says, graph the exponential equation of best fit and your scatter plot on screen. Based on the graph, how well do you think your model fits the data? Now, if you look here, this symbol is red. So that means the red line is our exponential equation. If you notice here, our exponential equation seems to hit almost every point on this scatter plot. So this model seems to fit better than the linear model. Because it hits almost all of the points on the scatter plot. Okay, problem number 10. It says, write a description of what the base of the exponent in your exponential model tells us about the growth of tuition since 1981. Again, more specific and detailed is better. Okay, now, one thing I want to tell you is this here. B is our growth factor. So we have first, let's just put B is equal to 1.0566. Now, whenever you have a digit in front of the decimal that's higher than 0, any digit higher than 0 that's in front of the decimal, that means that you have exponential growth. So, the first thing we could tell about B is that we have exponential growth. And we could put our growth factor is 1.0566. But our growth rate is, now, to get your growth rate, and I'm going to write this off to the side, you would take your growth factor and subtract 1 from it. So it'd be 0.0566. Then you'll move the decimal 2 places to the right and then make that into a percent. So it'll be 5.66%. And then we'll put per year. That is our growth rate. Remember, the growth rate is the percentage going up. The growth factor is just whatever you have in N for B. Now, we move on here to the next page. And this is actually our last page, 2427. It says, what is the correlation coefficient for your exponential equation of best fit? If we look here, wow, it looks as though instead of doing 2 decimal places, we have to do 3. Because if we did 2, that would take us to 1. So it'd be 0.998. Does this change your perspective on how accurately the model fits the data? And I would say no, because we saw that it was almost a perfect fit. 0.998 is almost a perfect fit. A perfect fit will either be +1 or -1. Now we go here to problem 12. It says, based on all of the work we've done in this portion of the lesson, which model do you think is the best choice for modeling the tuition data in the table? Why do you feel this way? Okay, first of all, I would list correlation coefficients. I'm going to write out what I'm doing. So we'll list the correlation coefficients. So for linear, it was R equals 0. And we could just, I'll go to 3 decimal places with this. So it'd be, if we go back up here, it'd be 0.971. Okay. And then the exponential is R is equal to 0.998. So the exponential model is a better fit because it has a higher correlation coefficient and is real close to 1. And that's what makes it better. Now, remember, your 2-5 check assignment is actually due today. Your 2-7 check assignment will be due tomorrow. There is no 2-6 check assignment. I just want to clear that up. There is no 2-6 check assignment. There is one for 2-5, which is today that you need to do, and then 2-7, which is tomorrow that you need to do. So, the next thing that we would do, and I want to get to this, we're going to start the review. We're going to do the first part of the review. So let me pull that up really quick. I'm going to pull up that review. All right, let me minimize this here. Okay, so this is the first part of the review. Now, we're going to do that. Okay, before we start, I want to show you all how to get to the review. And I know a lot of you most likely know how to get to the review, but I just want to go back over that. So you will go to your JetNet page and you will scroll down until you get to the folder that says exam review. You will click here on this folder and it has all the exam reviews. If you notice, the midterm has two parts to it. So we're going to go over part 1 today, and then tomorrow we're going to go over part 2. So what you would do is click here and download the review, and then you will be able to go over the review with me. All right, so now this is the review. Now I do want to show you something else with the review. Aside from giving you the problems, if you scroll down to the last 2 pages, it also has the answer key. So you can try this on your own and still look at the back for the answer key. Now, I'm going to go through most of this review. I'm not sure if I'm going to get through all of it, but at least you know that you will have most of it done. And if you have any questions, feel free to ask. Okay, so problem number 1. Now, one thing I want to spell out before we actually do this review is this here. You will not have multiple choice questions on your exam. You're going to have to figure it out and then put the answer in. So I'm just letting you all know. So don't expect multiple choice on there. Now, if it does turn out to be some multiple choice on there, that would be great. But I would just say expect no multiple choice. So, but I just had these multiple choice questions on here because they're still relevant questions. It says here, number 1, choose the one alternative that best completes the statement or answers the question. Express 0.92 as a percent. So we have 0.92. We want to express it as a percent. You can move this 2 places to the right, and that will give you 92%. Or you could take this 0.92, multiply by 100%, and it still will give you 92%. So your answer to number 1 is 92%. Okay, number 2. In this case, I'll write it down, it'll be C. Number 2, express 3.2 as a percent. So we'll take 3.2, we'll do it the same way we did up here. Move it 2 places to the right, it'll be 320%. Or you could take 3.2 times 100%, and it still will be 320%. And 320% here is B. Number 3, express 52% as a decimal. So 52%, there's a couple ways we could do this. We could take the decimal that's behind the 2, even though it wasn't shown. You know, it's assumed to be behind the 2. Move it 2 places to the left and drop the percent sign. That's one way of getting it. Another way of getting it involves using the decimals calculator. Well, I guess technically you don't need the decimals calculator, but I'll just use it anyway. All right. With the decimals calculator, percent means divided by 100. So we could just type in 52 divided by 100, and it'll give us our decimal. So that's another way of doing it. All right. Now, number 4, it says express 46% as a fraction or improper fraction. Now remember, percent means over 100. So 46% is 46 over 100. So now, you can put this in your decimals calculator. .46 over 100. Now that gave you a decimal, but they wanted you to write it as a fraction. You can press this here, and it simplifies the fraction for you. So it'd be 23 over 50. Or you could have just divided the top and bottom by 2. Okay, number 5. It says express 265% as a fraction or improper fraction. So we know 265% is the same as saying 265 divided by 100. Okay, so now we can go right back to our Desmos calculator. We could type in 265 over 100. It gave us 53 over 20. Now this is simplified all the way. So you can leave it as 53 over 20, or if you have to write it as an improper fraction, this is what you could do. 53 over 20. 20 goes into 53. Well, let's do this. You press this here. It's 2.65. So we know our whole number would be a 2 because of what's in front of the decimal. So all we're left with is 65.65, which is 65 over 100. So if we got rid of this 2, 65 over 100, and we simplified it, that would give us 13 over 20. Now that's another way of actually doing it. All right, next. We'll go here to problem number 6. Find the sales tax and total cost of an item that costs $269.95 if the tax rate is 5%. So now they want the tax rate. So let's do that first. We had $269.95 and they tell us the tax rate is 5.5%. So we'll multiply that by 0.055. So we'll take our calculator, the Desmos calculator. So we can have 269.95 times 0.055. So that'll give us $14, and we have to round the 2 decimal places, and 85 cents. Okay, so that's the sales tax. So this right here is the sales tax. Now they want us to do the total cost of the item too. So to do the total cost, we'll take the price of the item plus the sales tax. So it'll be $284.80, which will equal to the total cost. So that is the answer to number 6. Now number 7. It says a coat was reduced from $250 to $200. Find a percent decrease. Now remember, percent decrease is equal to new minus original divided by original. Now the new value of the coat, it went down to 200, so that's the new value. The original value was 250 divided by the 250. So this will give us a negative $50 over $250. So we could put that in our calculator. So we'll take negative 50 divided by 250, and that gives us a negative 0.2. And remember, we have to change that to a percent. So this will actually give us a negative 20%. But one thing I need to tell you is this here. Since we know that this is a decrease, we typically don't write the negative sign. So it'll just be the 20%. So it's a 20% decrease. And then in this case, the answer would be C. Okay, number 8. A math book with an original price of $369.99 is on sale for 80% off. Find the sales price. Okay, first of all, the $369.99. If we paid that full amount, that would be 100% of the cost. Okay? Now, they tell us with the directions that we're going to get 80% off. So the original was 100%. We're going to take off 80%, which means we're only going to pay 20% for this book. So if we take this amount and multiply by 0.20, then we will get our final answer. We don't have to go through 2, 3, 4 steps. You'll just take this $369.99, and multiply by 0.2. So you'll pay $73. Well, actually, it ended up being $74 when you round the 2 decimal places. So it'll be $74 you'll end up paying. All right. So now we go here to problem number 9. It says the average teachers and superintendent salaries for a school district was $40,727. 6 years later, the new average was $63,571. Find a percent increase to the nearest tenth of a percent. So remember, percent increase is new minus the original divided by the original. Now the new value was the 63,571 minus the original value was 40,727, and we'll divide by that. Now we'll take our calculator. So we will have 63,571. I'll put the division so we could get that fraction bar. And then it'd be minus 40,727. Then your denominator would be 40,727. So this will give us, if we round it to 3 decimal places, because I think the final answer has it like in 3 decimal places. So it'll be 0.561, which is 56.1%. That was the increase. 56.1%, which would be B. Now that's a nice increase. Okay, number 10. It says you buy $123 in clothes at a department store. You could choose between coupons that offer $20 off your entire purchase or 25% off. What would save you more money and by how much? Okay, so this is what we have to do. We already know it's $20 off the entire order. So that means that from the 123, $20 off, it'll be $103. Okay, that's how much money you will end up paying for that if you do the $20 off. But then here you have a 25% off coupon. Now we know 25% off. If we take 100% minus 25%, that means we will pay 75%. So we'll multiply this by 0.75. So we could take our calculator. So 123 times 0.75 will give us $92.25. Now, it asks us here which will save you more money. The 25% off coupon saves more money. And then they say by how much. So what you need to do, you need to find the difference of the two. So you would take the $103 minus the $92.25. So then you can put down, you save $10.75 more with the 25% off coupon. All right, so that took care of problem number 10. Now we go on to problem number 11. At one point in time, there were 46 Republican senators, 49 Democratic senators, and 5 who were independents. Find the percentage for each category, then the number of degrees that each category will cover in a pie chart. Okay, so first of all, there are 100 senators. So they wanted us to find the percentage. So I'm just going to abbreviate R for Republican, D for Democrat, and I for Independent. So the Republican will be 46 over 100, the Democrat will be 49 over 100, and the Independent will be 5 over 100. 46 over 100 is just 46%, because percent means divided by 100. 49 over 100 is 49%, and 5 over 100 is 5%. Okay, those are the percentages. Now they want us to find the degrees of each. So we have our percentages. I'm going to circle those. Now when we go for the degrees goes like this. You would take your percent and multiply it by 360. So 0.46 times 360, we'll put that in the calculator. So it'd be 165.6. 165.6 degrees. So this degrees for the Democrats, 0.49 times 360. So that'll be 168.84 degrees. And then finally, degrees for the Independent be 0.05 times 360. So that'll be 18 degrees. And for number 11, okay, that's it. So we have their percentages, we have their degrees. That's all they wanted here. Number 12, it says, a national survey on college students and work was conducted during the 2003-2004 academic year and reported on the website www.acenet.edu. The results are summarized in the pie chart. If one campus has 4,790 students, how many would you expect to work more than 20 hours? So when they say more than 20 hours, that's 21 or more. There's only 2 categories that had 21 or more hours. So they said, how many would you expect? So the first thing we would need to do is get the percentage, 21 and 19. So we had 21% plus 19%, which would be 40%. Okay, so we would take this 4,790 and multiply by the 40%, which is 0.40. So we'll put this in our calculator. 4790 times 0.40. which will give us 1,916, and that will be students. So that would be the answer to problem 12. Problem 13. It says the graph gives the areas of various college campuses in acres. Okay, estimate the area of the campus of Princeton University. Okay, Princeton University. All right, so if you look at Princeton, it's a little less than half between 0 and 1,000. So we know that should be under 500. So we have our two choices here between A, 400, B, 100. And we notice this covers a lot more ground than just to be 100 acres. So it had to be A. So 13 would be A, the 400 acres. Okay, now 14. It says two different situations are described that you can illustrate with the graph. For one of the two, it will be most appropriate to use a bar graph, and for the other, a pie chart would be a better choice. Social network use. A survey of 100 college freshmen found that 82 used Facebook, 10 used MySpace, 48 used Twitter, 60 used Instagram, and 33 used Google+. Test scores in a geology class with 32 students. 6 earned an A on the first exam, 12 earned a B, 7 a C, and 4 earned a D. Which data is best illustrated with a bar graph? Explain why you feel that way, then draw a bar graph representing the data. Okay, actually, the bar graph is better for social network use. And that is because a person can use more than one social network. Okay, now as far as drawing a bar graph, you're not going to have to draw a bar graph on the exam, so we don't have to do that here. But just to let you know, the reason being is because a person can have more than one social network that they use. Even though they tried to set this up, because we know pie charts are supposed, their percentages are supposed to equal 100, so they put 100 college freshmen. But when you total up how many used each, this does not total up to 100. It's more than 100. Okay, now 15. It says two different situations are described that you can illustrate with a graph. For one of the two, it would be most appropriate to use a bar graph, and for the other, a pie chart would be a better choice. So basically, it gave us the same scenario, but it says which data is best illustrated with a pie chart. And then that would be 15, it would be the test scores. Because remember, you only get one grade for a test. So the test scores are parts of a whole, and with only one score per person. So that would make it better for a pie chart. And I should put, so a pie chart is best. All right, now we move on to problem 16. It says, estimate the result of the computation by rounding the numbers involved, then to use a calculator to find the exact value. So what they want you to do is round first, and then they want you to find the exact value. So if we round in the numerator, we will add the square root of 17. we could round to an exact value, to a whole number. 4.9, we could round to 5. And then 7.1, we could round to 7. So it'd be square root of 17 over 2. All right. So if we did that, square root of 17 over 2, let's put that in a calculator. Actually, it should be over negative 2. Square root of 17 over negative 2. So that'll be approximately negative 2. So first of all, we could say it's approximately negative 2. All right. Now we want to do the exact value. So the exact value, put that in our calculator. I'll just scoot this over here so I'll be able to get a better view of it. So it'd be 16 point, what's that, 5649. That'll be the numerator. The denominator, well, I guess we could type it out as is. 4.9 minus, what's that, 7.1. Yeah, and the exact value would be negative 1.85. So our answer here would be A. So the exact negative 1.85, the answer would be A. All right. So now we go here to problem 17. It says, estimate your cost to live in an apartment for 1 year if the rent is $365 per month and utilities are $52 per month. Okay, so if we round this, we can make this 370. The 365 we can round to the tens place. That'll be 370. And the utilities we can round to 50. So that'll be about $420 a month. So we could say A. Wait a minute. Let's see. Oh, but they want us to do this for 1 year. So it wouldn't be A. We have to multiply this by 12. So, because they want to know how much it would be for a year, not just for 1 month. So we would take this and we'll multiply 12 times, and it'll be, what's that, 420, which would be 5,040, which would be C. So it'll be C, 5,040. So the answer would be C. That'll be the estimate. All right, 18. It says convert the following measurement to the specified measurement. Round to the nearest hundredth. So they want us to round to 2 decimal places. Now what I'm going to do, I'm going to skip over 18, 19, 20, all the way up to 22. Well, let me see, is all of these, because I want to do all of the measurements together. So let's skip down to 27 and I'll come back to the previous problems. Okay, 27. It says an advanced spacecraft can travel at 6.4 times 10 to the 7th meters per hour, which is 40,000 meters per hour. How long would it take to the sun? Okay. I'm going to have to skip 27 as well. All right, 28, which is scientific notation. It says here with 28, at a particular point in time, it took the U.S. government this many hours to spend $1 million. Write the number in scientific notation. Now, first of all, we know with scientific notation, when we start off with 0 point something, we know that it's going to end up with a negative exponent. So that would X out D. So if we move that decimal, let me put this. So we move this decimal 1, 2, 3 spaces. So it'd be 1.9663 times 10 to the negative 3 power. So that would be C. All right, problem 29. It says at a certain time, the number of people in the United States was 307,561,000. Write the number in scientific notation. Okay, let me write out this number here. With the decimal here, we'll go 1, 2, 3, 4, 5, 6, 7, 8. We move 8 places to the left, so it'd be 3.07561 times 10 to the 8th power, which would be B. Okay, 30. This year, 10 faculty members are to receive promotions at a community college with 3 campuses. The number of promotions will be apportioned according to the number of full-time faculty members as shown. Find A, the standard divisor, and B, the standard quota for each district. Round answers to 3 decimal places. Okay, so now we're going to get into apportionment. So we're going to first do A, which is the standard divisor. So the standard divisor I'm going to abbreviate is the total population divided by the number of seats. Now in this case, this would be the number of promotions. Okay, the total population, if you look here at problem number 30, the total population is 410. So we'll take 410 and divide it by the number of promotions, which is 10. So our standard divisor would be 41. Okay, now, our next step. They ask us to find the standard quota. So that's B. So the standard quota, and we will have to do it by each campus. So I'll put S for South, C for Central, and N for North. So remember, the standard quota is the population of the district. The district in the South was 119. All over, it'll be the standard divisor, which would be 41. And then Central would be 140 over 41. And then North would be 151 over 41. Now, they told us to round the answers to 3 decimal places. So we need to get our calculator. So we would take 119 divided by 41. That'll give us 2.902. Then we would take the 140 divided by 41. And it'd be 3.415. And then we would take 151 divided by 41, which would be 3.683. Okay, so if you look here, our A of 41, this actually is D. D is our answer. All right, now, I believe 31 is the last problem, and then we'll go back to do those other problems. Okay, 31, an automotive repair company has 4 stores in a large city. The owner purchased 15 diagnostic computers for the business. The number of cars serviced per store each month is given below, along with the standard quota. If the standard divisor, now they tell us what the standard divisor is, so I want to write that down. The standard divisor is 36.7. A, use Webster's method to determine how many computers each store should get based on the number of cars serviced. And B, write the modified divisor used. Round the divisor to the nearest 10. Now listen, we're going to change this slightly. We're going to use Hamilton's method. We're not going to use Webster's method. So the answer in the back will be a little different, but we're going to use Hamilton's method. Okay, so With Hamilton's method, so we will have the store. We'll have the different stores. Now I know they didn't separate these with lines, but I need to for myself. So we have the cars serviced, and then the standard quota. So we have, let's see, 122, 109, 192, 127, standard quota, 3.32, 2.97, 5.23, 3.46. Okay, so you know we need to do the lower quota. Lower quota is just the number in front of the decimal, so it'd be 3253. Okay, so we'll add up the lower quota. Well, we could do the upper quota as well. Upper quota would be 4, 3. We'll just add 1 to the lower quota. So we'll add this up. That's 5, 10. That'll be 13. Now we're trying to get 15 diagnostic computers. So what we would do with Hamilton's method, we're 2 seats short. So we look behind the decimals of the standard quota, and we look for the 2 highest values behind the decimal. And that'll be this 9.7 and 4.6. So our answer here would be, I'll put computers here for our answer. So we'll use the lower quota for 1, which is 3. Since 2 have one of the 2 larger values, we'll use this upper quota. 3, we'll use this lower quota. And since 4 had one of the 2 larger values, we'll use the upper quota. And when we add all this together, it gives us 15. So this right here will be our answer. 1 gets 3, 2 gets 3, 3 gets 5, and 4 gets 4. And that'll take care of problem 31. Okay, class, we're going to go back to those problems that I told you that I needed to skip over initially. So we're back to problem number 18, where it says convert the following measurement to the specified measurement, round to the nearest hundred. So we want to go, problem 18, 52 decimeters is equal to blank inches. Okay, so now on page 64 of your course pack, we do have these charts here that are available to us to give us the measurements that we need. So with that being said, we want to go from decimeters to inches. So we would go down here to conversion between systems, and we're doing length. Now, what we have here that's equivalent to inches is centimeters. So we know that 2.54 centimeters is equal to 1 inch. But we want this in decimeters. So first of all, we need to go here to the metric system. Now, decimeters is a little larger than centimeters. It takes 10 centimeters to equal 1 decimeter. So basically what we would do, we would take the 52 decimeters and we would multiply it. So it takes 10 centimeters to equal 1 decimeter. Now this would change this from decimeters to centimeters. Then we would need to change the centimeters to inches. So we would have 2.54 centimeters is equal to 1 inch. So now we could put this over 1. The decimeters will simplify out. The centimeters will simplify out. So this will give us 520 over 2.54, and this will be inches. So now we need to take our Desmos calculator. Let me pull that back up. And then we would Let me just erase out a couple of these here real quick because we did a lot of work earlier, a lot of work. All right, so we would take 520 divided by 2.54, and that would give us 204.72, and that'll be inches. So that would give us D. D would be the final answer. Okay, so now we go to problem 19. It says convert the following measurement to the specified measurement. Round to the nearest hundredth if necessary. Now, if you look here, we have 7,605 gallons to kiloliters. So 7,605 gallons, and we want to convert that to kiloliters. So we will go back to our chart on page 64 of your course pack, and we're going conversions between systems. So we want to go, if you look here, gallons and liters, gallon goes to liters. So we need to convert liters to kiloliters. So if we go up here to liters, kiloliters is 3 spaces away from liters. So it takes 1,000 liters to equal 1 kiloliter. So what we would do first, we would take the 7,605 gallons and multiply it. We would take 3.79 liters over 1 gallon. That would get rid of gallons, and now we're at liters. Now it takes 1,000 liters to equal 1 kiloliter. And then now we can solve this. We could put this over 1. Gallons will simplify out. Liters will simplify out. So now we have to multiply. Let us get this calculator here. We will have 7,605 times 3.79, and that will give me in the numerator 28,822.95. It'll be all divided by 1,000, and this will be kiloliters. Now when we divide this by 1,000, well, let me take this down to the next value here. We divide all this by 1,000, then it will give us 28.82 kiloliters. Now, it looks as though there was a little rounding error here, but it should have been 28.82, so it's just slightly off. So with problem 19, they were looking more at C, so it's actually approximately C, so it's very, very close. All right, now we go here to problem 20. A chemistry teacher has 3,581 grams of a substance, and he wants to separate the substance into 8-ounce jars. How many 8-ounce jars can he fill? So we need to take this 3,581 grams, and we need to change it to ounces. So let's do that. We're going to look back here. We want to change grams to ounces. So grams is weight, and it just so happened that we don't have to do as much as we did in the other problems because grams and ounces are already set up. So it takes 28.3 grams to equal 1 ounce. So the grams will simplify each other out. You have 3,581 over 28.3, and this will be ounces. So we'll pull up our calculator. So you have 3,581 divided by 28.3. So it'll be 126.54. All right. So that's how many ounces you have. But remember, we're trying to find out how many 8-ounce jars we could fill up. So now we would take this and divide it by 8 ounces to see how many jars we could fill up. So we would take our calculator and we would divide this by 8. And that would give us 15.82 jars. So we will go back here, and we know 15.82 jars would be almost 16. So it'd be C. All right. Now we move on. We go here to problem 21. It says a model of the Space Shuttle Challenger has a scale of 1 to 32. The actual shuttle was 122 feet in length. How long is the model? Okay, now, so we have 1 to 32. This is the actual. The 1 is the actual, 32 is the model. All right. Well, actually, I'm sorry. 1 is the model and 32 is the actual. So what we would do, we would take this 122 feet and multiply it by 1 over 32. So it would be for every 1 foot of the model is 32 feet of the actual. So this would be 122. These feet would simplify out, be 122 over 32 feet. Now, we need to simplify this, and we can use our calculator. So we could take 132 or 122 divided by 32. And we can make that into a fraction. So that would be 61 over 16. Now, in the directions, they ask us here to write, rather than writing a decimal answer in feet, write a number of feet with leftover inches. So we have 5 feet 8 inches as our model. So this is what we would need to do. Let me go back to decimals. First, I would make this back into a decimal. So we know we would have 3. So that'll be 3 feet. Now we have to figure out how we're going to get the inches. So what we could do, we could subtract 3 because we got rid of the feet. Now we want to change these feet here to inches. So we want to take this 0.8125 feet and make that into inches. Well, we know it's 12 inches in 1 foot. So the feet would simplify each other out. So now you will have 0.8125 times 12 inches. So we will multiply that out, 0.8125 times 12, and that would give us 9.75 inches. Now, according to this, so we would have 3 feet, 9.75 inches. But if you notice here, we do not have anything that has a decimal for the inch portion. But we do have this fractional piece here, this 3/4. So to check it, to make sure that we got this correct, you could do this. You could type in 0.75 and hit this here, and it will give us the fraction of 3/4. So this would be 3 feet and 9 3/4 inches. All right, now we move on to problem 22. Now problem 22, it says forensic scientists often examine scaled up crime scene photos to search for evidence that might be hard to see at regular magnification. Studying bite marks on a photo of a victim's leg at 400% magnification, a technician measures the distance between two punctures from the bite to be 116 millimeters. What is the actual distance between the punctures? Okay, so 116 millimeters is at 400% magnification. So that means that this has been increased by 400%. So basically what we need to do is take this 116 millimeters and multiply it, and divide it by the 400%. So we have 116 millimeters, and then 400% is 400 over 100. So we have 116 millimeters times 100 over 400. Now we can put this in our calculator. I know we can simplify the fraction, but since we can use this calculator, you might want to check it on the calculator instead of trying to do it by hand. So we could take 116 times 100, and then we could divide all of that by 400, which will give us 29. So this would be 29 millimeters. So that would be our final answer, and that answer actually would be A. And then going back up here to 21, that answer would be D. All right, now we move on to the next page. Problem 23. It says using English metric conversion for area given in the table to convert the following measurement to the specified measurement. Round to the nearest hundredth if necessary. So with 23, we have 6,824 square meters is supposed to equal to some value that's square yards. Now, if you notice here, we have square yards to square meters. So we could do a quick conversion. So we want to change these square meters to square yards. So the square meters will go in our denominator, and the square yards will go in our numerator. So the square meters will simplify each other out. So you have 6,824 square yards all over 0.836. Now we will put this in our calculator, and we'll have 6,824 divided by 0.836. So this will give us 8,162.68 square yards. And that will be B. Now, 24 is actually going to be the last problem that we complete. 25 through 27 you don't have to worry about on this exam. So 24 would be it from this review. It says a major corporation's profit projection for the recent fiscal year was 3.3 billion. The actual profit was 3 billion. Find the actual difference and relative difference in percent form between the company's projection and the real profit. Okay, so remember, we will have, when we're doing the estimate here, the relative difference during the estimate, we do the estimate minus the actual divided by the actual. So the estimate is 3.3 because we know we're just dealing in billions. The actual is actually 3 divided by 3. So 3.3 minus 3 will give us 0.3 all over 3. Now 0.3 divided by 3, let's put that in a calculator. 0.3 divided by 3 will give us 0.1. Or we could write that as 10%. Okay, now let's answer these questions. It says find the actual difference. When we do the actual difference, that would just be 3.3 minus 3, which would be 0.3 billion. This would be the actual difference. And just to write this out, the actual difference is the estimate minus the actual. Okay, now that's the actual difference. Now they ask us for the relative. Now we did the relative already, which is this 0.1 or 10%. Everything is in percent, so it'll be 10%. So our answer here is supposed to be 0.3 billion and 10%, so our answer should be C for problem 24. Now, in the back, it has it as a different answer, but the answer is actually C for problem 24. And we are done with the review. Now again, the check assignment for 2-5 is due today. The check assignment for 2-7 is due tomorrow. Your midterm exam is actually going to be Monday and Tuesday of next week, unless we made other arrangements. Now, it will be during class time from noon to 1 p.m. And I will be sending you out a Zoom code because I need to see you all when you all take the midterm. So I will finish up the rest of this review tomorrow, and I want you all to have a very good day.